Hi guys, in today's video we're going to look at complex ions, common ligands, looking at monodentate, bidentate and multidentate ligands. We're going to look at how they're formed, looking at hybrid orbitals, and finally an exam style question.
Well, our complex ions are transition metal ions bonded to ligands by coordinate bonds. Now you'll notice some new terminology here, so let's just go through and describe that. Well, our ligands, these are species that donate a pair of electrons to form a dative covalent bond. And this dative covalent bond is known in this instance as the coordinate bond. And we'll have a greater look at what these coordinate bonds are when we look at the structure of our complex ions. But first, let's have a look at some common ligands. Well, we said how our ligands form these coordinate bonds, these dative covalent bonds. And they do this because they have a lone pair of electrons in their outer shell, which they can use to form this bond. Ligands can take a number of different forms. They can be monodentate, donating one pair of electrons, bidentate, donating two pairs of electrons, or multidentate, donating multiple pairs of electrons. So let's have a look at some common monodentate ligands. Water is an example of a monodentate ligand, and you can see we write it as OH2 with the lone pair of electrons next to the oxygen to signify that the lone pair belongs to the oxygen. Water is a neutral ligand. We have ammonia, which is NH3, and the lone pair belongs to the nitrogen. Again, ammonia is neutral. We have cyanide, where the lone pair belongs to the carbon. Now, cyanide has a 1 negative charge, so it's 1 negative is its charge. We have chloride, which has a negative charge again, and the lone pair is written on the left-hand side. And we have hydroxide, which again has a negative charge, and the lone pair is written next to the O to signify it belongs to the oxygen. So let's have a look at a complex ion and how these ligands fit in. Well, here we have this complex ion, which involves iron and 6 molecules of water. So the way we would draw this would be like this, and you can see the lone pair is always drawn next to the oxygen, and we kind of just fit our H2 molecule around that to signify that the lone pair of electrons belongs to the oxygen, and there's no mistaking it to belonging to the hydrogens.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, click the button. Join me today and together let's make A-level chemistry a walk in the park.